Welcome to Agial Language School. Today we are going to explain equality of the areas of two parallelograms. The parallelogram is a quadrilateral in which each two opposite sides are parallel, like A, B, C, D here. A, B, C, D is a parallelogram because each two opposite sides are parallel. The area of the parallelogram. Area of parallelogram equals base multiply height. What is the base and what is the height? To find the area of parallelogram, you should to know the base and the height of it. What is the base and what is the height of the parallelogram? The base of the parallelogram is any side of it. So, BC, CD, DA or AB consider a base. Again, the base is any side. So, we can say AB is a base, BC is a base, CD is a base, DA is a base. Any side of the sides of the parallelogram is a base. And what is the height? Each base has a corresponding height. What is the height? The height of AD and BC is the perpendicular distance between them. The perpendicular distance between them. This is the height of AD and BC. Any perpendicular distance between them. And what is the height of DC and AB? Also the perpendicular distance between them. So each parallelogram has two bases and two heights. AD and BC consider a base and their height, the distance or the perpendicular distance between them. AB and CD consider another base and their height is the corresponding distance between them. Again, here A, B, C, D, AD and CB consider one base. Their corresponding height is the perpendicular distance between them. This is the height. And AB and CD consider another base. Their height is the perpendicular distance between them. And as you see, the long base has a short height and the short base has, a long height. Don't forget, short base has long height and the long base has short height. Now you know the base and the height. Here, if ABCD is a parallelogram, then AF equals what centimeter? We want to find the length of AF. AF is what in the parallelogram? AF is a height of the parallelogram. So to find it, we divide the area by its base. What is the base of AF? The base of AF is DC. To find AF, as we see, AF is a height. So to find it, divide the area of the parallelogram by its base. The base of AF is what? Yes, is DC. So divided by DC. DC equal to AB. So DC equals 5 centimeter. This is DC. And what is the area of the parallelogram? We don't know what is the area of the parallelogram. So you should to find it first. To find the area of the parallelogram, as we said before, the area of parallelogram equals base multiply height. Search about base and another height. Here we have the base AD and its corresponding height, which is AE. So first, the area of the parallelogram equals base multiply height. The base here is AD, so it's 8 multiplied by its height is AE, it's 4. So the area is 32 centimeter square. Now we can find the length of AF. The area of parallelogram is 32 divided by the base of AF. The base of AF DC equals 5 centimeter. So it's what? 32 divided by 5 equals, yes, 6 and 2/5 centimeter, or 6.4 equals 6.4 centimeter. Theorem 1. Surfaces of two parallelograms with common base and between two parallel straight lines, one is carrying this base, are equal in area. If we have two parallelograms and the two parallelograms are between two parallel straight lines, we have two parallelograms like A, B, C, D, and A, B, E, F. Here we have two parallelograms. A, B, C, D, and A, B, E, F. As we see, the two parallelograms have a common base, which is AB, have a common base, which is AB. AB is a common base for the two parallelograms, and the two parallelograms are drawn between two parallel straight lines, right? So the area of the parallelogram A, B, C, D equal to the area of the parallelogram A, B, E, F. Again, if we have two parallelograms with a common base and drawn between two parallel straight lines, then the area are equal. Then the area of parallelogram A, B, C, D equal to the area of parallelogram A, B, E, F. Also, the parallelograms with bases equal in length and lying on a straight line, while the opposite sides to these bases are on another straight line, are equal in area. If we have two parallel straight line like this, and we have parallelograms 2, 3, any number of parallelograms. The parallelogram A, B, C, D, and the parallelogram X, Y, Z, L. The two parallelograms don't have a common base, but they have equal bases. Here, LZ equal to DC. We can also say the area of the two parallelograms are equal. The area of the parallelogram A, B, C, D equal to the area of parallelogram X, Y, Z, L. Why? Again, since the two parallelograms A, B, C, D and X, Y, Z, L, two parallelograms, and they have equal bases, and LZ equal to DC, then you can say that the area of parallelogram X, Y, Z, L equal to the area of parallelogram A, B, C, D. Also, the parallelogram and the rectangle with common base and between two parallel straight lines are equal in area. If we have parallelogram and a rectangle, parallelogram like A, B, C, D, and a rectangle like A, B, E, F, they have a common base which is AB, so the area of the parallelogram equals the area of the rectangle. Since the parallelogram A, B, C, D and the rectangle A, B, E, F have a common base which is AB, then the area of the parallelogram equal the area of the rectangle. Here the area of the parallelogram equal to the area of the rectangle. In the opposite figure, ABCD is a parallelogram in which measure of angle ABC equal 150 degree, AD equal 12 centimeter, AB equal 8 centimeter, E belong to the ray CB, and AE perpendicular to CB. Find the area of the parallelogram ABCD. We want to find the area of the parallelogram ABCD. As we said, to find the area of any parallelogram, you should to know base and height for it. Okay, here we have two bases, AD and AB. The height of AD is, yes, AE. So, find the length of AE first. How to find the length of AE? We have here ABC equal 150. So, we can find the angle ABE. It will be, yes, 30 degree. And now AEB is right angled triangle and measure of angle B is 30 degree, so it's a 30-60 triangle. So AE equal half AB, it will be 4 centimeter. Now we can find the area because we have the base and its corresponding height. How to write this? First, we get the measure of angle ABE, right? How? Here we have CBE on the same straight line, so we can subtract from 180. Since C, B, and E are on the same straight line, then measure of angle A, B, E equal 180 degree minus 150 degree equal 30 degree. And since A triangle AEB is right angled triangle at E, then triangle AEB is a 30-60 triangle. Then AE equals half AB equals 4 centimeter. Then the area of parallelogram ABCD equal base multiply height. The base here is AD, it's 12, multiply height, which is 4, so it's 48 centimeter square. Another one. In the opposite figure, ABCD and EBCF are two parallelograms. E belong to the straight line AD and F belong to the straight line AE. Prove that the area of triangle ABE, the area of triangle ABE equal the area of triangle DCF. As we see, we have two parallelograms A, B, C, D and EBCF. The two parallelograms have a common base, yes, CB, and they draw in between two parallel straight lines, AE and CE are parallel. Why? Because ABCD is a parallelogram, then AD parallel to CD from the properties of the parallelogram, and also EBCF is a parallelogram, so this is parallel to this from the properties of the parallelogram. Then we can say AF parallel to CD. Okay? How to write this? First, the two parallelograms EBCF and ABCD have a common base CB and AF parallel to CB. Then the area of the parallelogram ABCD equal to the area of the parallelogram EBCF. The area of ABCD equal to the area of EBCF. If we subtract the area of the shape EBCF from both sides, we will get what? Yes, the area of triangle equal the area of this triangle. So here subtract the area of the shape EBCD from both sides. Then the area of triangle ABE equal to the area of triangle DCF, and this is required. Another example, in the opposite figure ABCD is a rectangle, AE parallel to DF. Prove that the area of the figure ABCM equals the area of the figure DMEF. First, ABCD is a rectangle, AE parallel to DF. We want to prove that the area of ABCM, this is equal to the area of the figure DMEF. First, ABCD is a rectangle, right? So AD is parallel to CB from the properties of the rectangle, right? And F belong to the ray BC, right? So EF also parallel to DA, and we have AE parallel to DF given. Then AEFD is a parallelogram. First, I want to prove that the shape AEFD is a parallelogram. How? Be with me. Since ABCD is a rectangle, then AD parallel to CB, right? From the properties of the rectangle. And since F belong to the ray BC, then AD parallel to EF. This is number 1. And since AE parallel to DF given, this is number 2. From 1 and 2, this parallel to this and this parallel to this, then A, E, F, D is a parallelogram, right? And since the rectangle A, B, C, D and the parallelogram A, E, F, D have a common base, AD, and they draw in between parallel lines, which are AD and BF, then the area of rectangle equal the area of parallelogram, right? The area of rectangle, this part, is equal to the area of parallelogram, this part. Subtract the area of triangle AD, or this part, we can say M, or what? Yes, M. Subtract this part, AMD, we will get the required. Subtract the area of triangle AMD from both sides. Then the area of the figure ABCM equals the area of the figure DMEF, which is required. We have finished our lesson for today. Have a nice day and goodbye.